In this video, we want to look at some exam questions on aldehydes and ketones. This is our first question, and this question reads, how many acidic hydrogen atoms does each of the following molecules have? So let's look at these molecules that this question is referring to.
So these are the molecules that our first question is referring to.
This is the information that we're required to know before we can attempt question 1. And this information is coming from module 5, which is on aldehydes and ketones. So basically what we need to understand here is the acidity of the alpha hydrogen atoms of the aldehydes and ketones. So we actually know that both aldehydes and ketones have got this carbonyl group. And the carbon that is right next to the carbonyl group is called the alpha carbon. So you can see this carbon which is right next to the carbonyl group is called the alpha carbon. So the hydrogen atoms that will be attached to this alpha carbon will also be called alpha hydrogen atoms. So you can see we have this hydrogen. This hydrogen is actually the alpha hydrogen. So this hydrogen is acidic. So the acidity of this hydrogen atom is due to the strong electron withdrawing effect of the carbonyl group. So this carbonyl group is an electron withdrawing group. And because of its electron withdrawing effect, it makes this alpha hydrogen to be acidic. Having understood the acidity of the alpha hydrogen atoms of the aldehydes and ketones, we're ready now to tackle this question. So let's look at molecule A. How many acidic hydrogen atoms does this molecule have? Well, for us to answer that question, we need to look for the alpha hydrogen atoms here. So we know that this particular molecule has got 2 alpha hydrogen atoms. So we go for this carbon right here and also this carbon right there. So we have 2 alpha carbon atoms. So molecule A has got 2 acidic hydrogen atoms. You are considering this alpha carbon right there. It only has 1 alpha hydrogen. So 1 alpha hydrogen. Then you also have this other carbon. This is also another alpha carbon. And it also has only 1 alpha hydrogen. So you have a total of 2 acidic hydrogen atoms. When you consider molecule B here, you've got this group here, the pH. So pH just means phenyl. And this is how this molecule looks like. So you can see this thing here. So this particular group here is the phenyl group. So when you see pH, just know that what it means is that it just means phenyl group. So when you look at this particular molecule, this molecule does not have any acidic hydrogen. Quite okay, we have the alpha carbon. So this is the alpha carbon here, but this alpha carbon does not have any hydrogen atom. Therefore, molecule B does not have any acidic hydrogen. This hydrogen that you see here, on the other hand, this hydrogen is not the alpha hydrogen. So for molecule B, we can say we don't have any acidic hydrogen. So the number of acidic hydrogen atoms for this particular molecule is 0. Let's move to molecule C. When you look at molecule C here, so you have 2 alpha carbon atoms. So you have this carbon atom, that carbon there is an alpha carbon, and that carbon has got 2 alpha hydrogen. When you also consider this carbon right there, that is also another alpha carbon. And this particular carbon only has 1. So we have a total of 3 acidic hydrogen atoms for molecule C. Let's move to molecule D. When you look at molecule D, it has got 2 alpha carbon atoms, this carbon and also this other one. So this molecule has got a total of 4 acidic hydrogen atoms. So when you look at this particular alpha carbon, it has got 2 acidic hydrogen atoms, and also this other one also has got 2 acidic hydrogen. So overall, this molecule has got a total of 4
acidic hydrogen atoms. Let's move to molecule E. This molecule E has got two alpha carbon atoms. Yeah, this is the alpha carbon atom, the carbon that is just right next to the carbonyl group, or the carbon that is next to the functional group. So you have one alpha carbon right there. You also have another alpha carbon right there. So now this alpha carbon does not have any acidic hydrogen. So you can see no acidic hydrogen for that particular alpha carbon. While this other one, the other alpha carbon, has got one acidic hydrogen. So this has got a total of one acidic hydrogen atom. So this is how you can actually determine the number of acidic hydrogen atoms from an aldehyde or a ketone. So you just go for the alpha carbon, you go for the alpha carbon, then count the number of hydrogen atoms connected to that alpha carbon.
This is our next question. What is the major product of the following reaction? So now what you have here is a ketone. This is a ketone, and this ketone is reacting with this reagent. So you have hydrogen there on top and also a proton at the bottom, indicating that an acid is used in this particular reaction. Now let's look at what we need to know for us to attempt this question. This question is simple if you know what you need to know for you to answer it. So let's look at what we need to know for us to be able to answer this question confidently. One of the most important reactions that we need to know if we're to answer our question is this particular reaction. And this reaction is called the addition of ammonia and its derivatives. So what we're basically saying here is that aldehydes and ketones can react with ammonia and its derivatives. So what you see here, this is the general form of this particular reaction. So you can have an aldehyde. So in this case, you have this carbonyl and it can react with this reagent. So this, I have actually magnified this here. So these two are just the same. So what you basically have here is that you have two hydrogen atoms, then you have a nitrogen atom, and also you have Z. This Z can be any of these groups listed here. So if we put hydrogen where there's Z here, it means that we want to have ammonia, and ammonia is going to react with this carbonyl group to produce this intermediate, and finally this is going to be our product. So if Z here is this alkyl group here, if you have an alkyl group this on this letter where there's Z, then it means that you're going to have this as your product. So where there's Z, you just put that alkyl group. So Z can be an alkyl group, it can be an aryl group, it can be an hydroxyl group, it can also be this particular group, the amino group, it can also be any of these groups listed here. So if I decide to put NH2 where there's Z here, it means that I'm going to have hydrazine, and that is what we have in the question. Our Z in the question is NH2. We're ready now to tackle this question, and we know that this question is being derived from the reactions of ketones and aldehydes. And this particular reaction is nothing but the addition of ammonia and its derivatives. So for you to predict the product of this reaction, it's very simple. So what you do is you have to remove two hydrogen atoms from hydrazine. Then you also remove the oxygen atom from the carbonyl group. So when you do that, then you connect the remaining parts. So this means that this double bond is going to be connected to this particular hydrogen. So there will be a double bond between this carbonyl carbon and the hydrogen from hydrazine. So that is basically what you do for you to predict the product of such reactions. So this means that B is the correct answer. Let's look at our next question. For the following reaction, pick out the most suitable reagent. So this is the chemical reaction that we have. We have a ketone which is being converted into an alcohol. So now what we need to do is to select the correct reagents that can convert this given ketone into an alcohol. This is the information that we're supposed to understand for us to answer this question. And this information is concerning the reduction of aldehydes and ketones. So you can reduce aldehydes and ketones to alcohols. Aldehydes and ketones are reduced to primary and secondary alcohols, respectively, by sodium borohydride and lithium aluminum hydride. So basically, what we're saying is that for you to reduce aldehydes and ketones, you need to have either sodium borohydride or you can also have lithium aluminum hydride. So let's check our answers. A is not the correct answer because we do not have either lithium aluminum hydride or sodium borohydride. But when you go for C, we have sodium borohydride, then we have HCl and water. So this is the correct answer. If we have these reagents, we can convert this given ketone into an alcohol. This is our next question, and it reads, so we have this reactant. This reactant is nothing but an aldehyde, and it is reacting with hydrogen cyanide. So we need to pick out the major product out of all these options that have been given. So for us to answer that question, we're supposed to know this information. And this information is nothing but the addition of hydrogen cyanide to the carbonyl group. So aldehydes and ketones are able to add the cyanide group to the carbonyl group. So this is how the reaction takes place. So this cyanide has to react with the base and the cyanide ion is going to be formed. Then this cyanide ion is a nucleophile now because it is electron rich, and so it is going to attack the carbonyl group. And so you can see this is the intermediate that is formed when the cyanide ion attacks the carbonyl group. And the last step involves the addition of a proton to the negatively charged oxygen. So this oxygen is negatively charged, and so a proton is added to form this final product. So this is how hydrogen cyanide reacts with aldehydes and ketones. So basically, when you perform this reaction, what is going to happen is that this hydrogen cyanide is going to be added to the carbonyl group. So this hydrogen atom is going to add itself to the oxygen, and this double bond between this oxygen and the carbonyl carbon is going to break. So there'll be a single bond here. Hydrogen is going to add itself to this oxygen, then this CN, this part, is going to add itself to this carbonyl carbon. Okay, so that is what we expect when we perform this reaction. So this is addition reaction, addition of hydrogen cyanide. And so we expect to have this as our major product. So you can see here, the hydrogen has been added to the oxygen, then the double bond has been broken, so we only have a single bond. Then the cyanide ion, the cyanide ion is going to bond to the carbonyl carbon. From the following reactions, A to D, pick out those which lead to the formation of 1-phenyl ethanol. Please select all that apply. So, among all these reactions given, all these 4 reactions given, we need to select the ones that will lead to this molecule being formed. So now let's analyze these reactions. This question has got 3 answers. A is the correct answer, C is the correct answer, and D is also a correct answer. So if you perform these 3 reactions, you're all going to get this required product. Now let's look at these 3 reactions in details. So this first reaction, reaction A, is nothing but the addition of Grignard reagents to the carbonyl group. So when you react an aldehyde with Grignard reagents, what is going to happen is that this Grignard reagent is going to add itself to the carbonyl group. So this oxygen from the carbonyl group is going to be converted into an alcohol. So hydrogen is going to be introduced to this oxygen. Then this double bond here, this double bond that you see, is going to break. It's going to turn into a single bond. Then this alkyl group, the alkyl group from the Grignard reagent, so in this case we have methyl group.
this is going to be added to the carbonyl carbon. So, so two things are happening here. Hydrogen is going to be introduced to the oxygen of the carbonyl group. Then the alkyl group of the Grignard reagent is going to be added to the carbonyl carbon. So this is what happens. So this answer is also correct because it is going to give us the required product. So this reaction is C, and this particular reaction is nothing but the reduction of carbonyl groups. So by now we know that aldehydes and ketones are reduced to primary and secondary alcohols respectively by sodium borohydride. So this is a ketone and we have sodium borohydride. This can reduce this ketone to a secondary alcohol. So this particular reaction is also going to give us our required product, which is the molecule given above. So this reaction is same as the first reaction there. So what you have here is a Grignard reagent, then this is an aldehyde. So when you perform this reaction, what is going to happen is that the Grignard reagent is going to add itself to the carbonyl group. So in other words, what is going to add itself to the carbonyl group is going to be this pH, which is the alkyl part. Then the carbonyl group, so this molecule is same as this. Okay, you have hydrogen this side, then you have methyl group Me. So when you add this Grignard reagent, this pH from the Grignard reagent is going to add itself to the carbonyl carbon. Then this double bond here is going to break. It's going to be a single bond. So it's going to be a single bond. Then the hydrogen atom is going to be added here. Okay. So this is going to give us our required product.